Okay, so meanwhile, while other students are joining, last time I have given you one activity, that is you need to study the DSP architecture, DSP processor architecture, right? Okay, so I have shared you the link, and I hope everyone has uh, gone through that video. So today we'll catch up from there, and then we will discuss architecture as well as various additional peripherals in DSP architecture. Okay. Also, I have created one task or activity in the Google Classroom, that is you need to draw very neat and clean diagram of DSP architecture, and then you have to explain all the functional units. Okay. So the data flowing path जो direction है, that you have to be very careful while drawing that architecture. Okay. I think nobody will interrupt now, so we'll start. Uh, so let's quickly revise. That is DSP processor. We know that the DSP processors are microprocessors, and these DSP processors, the input out to the DSP processor is a real world signals. When I say the real world signals, it means voice, audio, video, temperature, pressure, position. Okay, and these signals are then digitalized, and then processors mathematically manipulate these signals. Okay, so it means that DSP processors are designed to perform mathematical operations like addition, subtraction, multiplication, division, and they perform all these operations, mathematical operations, very quickly. So we will let's look at the architecture and understand how these operations are performed very quickly. Okay. So this is the architecture. I hope everyone has gone through with that video and now can able to explain function of each and every unit. Okay. So let's just start with the architecture. So in this DSP architecture, just wait. Someone has just joined. Okay, so in our syllabus, we are going to study the architecture of DSP processor. So DSP processor is TMS 320C67XX DSP architecture. Okay, so this is a DSP processor which belongs to a Texas Instrument. Okay, and this is the overall architecture of DSP processor. So here, first of all, let's look at the unit or sections of each and every section of architecture. So there is first of all program memory. Then we can see here there is a data memory. Then there is a DMA and EMIF unit. Then this whole part is a CPU. Okay, the CPU is belongs to C6000 family CPU, which supports all C6000 family CPU. Okay, then there is a additional peripherals, and this CPU has control register as well as interrupt handling services. Okay, so these are the functional blocks present in DSP architecture. Okay, so how many students have actually gone through the video of DSP architecture, which I have posted in the Google Classroom? Everyone has done it. You can write it into the chat box. Everyone has gone through that video, or should I have to explain? Okay, let's quickly revise. So let's start with the architecture, and then we'll also study the additional peripherals. Okay, so as we have seen that in this architecture, basically all whole architecture is divided into four blocks. First block is your data memory and program memory. The second block is the whole CPU block. The third block is DMA, comma EMIF unit, and then there is a fourth block which is a additional peripheral which include timer, serial ports, and so on. Okay, now here we can see that there is a separate program memory and separate data memory. As we know that DSP architecture is based on hardware architecture. Okay, this is a computer architecture, hardware architecture, where the data memory and program memory are separate. Okay, so here we can see that there is a separate data memory and separate program memory. Now let's come to the CPU part. Okay, so the CPU is called as a central processing unit, where every instructions is processed into the CPU. Okay, as well as all the instructions and signals are controlled and handled by this CPU unit, right? So in this CPU, there is a first block that is program fetch, then there is an instruction dispatch, and third is the instruction decode. So every time whenever it wants to access any data or information, okay, the sequence of the execution will be, first of all it will fetch the data from the sorry, it will fetch the instruction from the program memory first. Second is it will dispatch the instruction, and third step will be instruction decode. So this way your data the whatever information is present in the program memory is fetch, dispatch, and then decode. Okay, these are the three steps. Once it is done, After decoding, whatever data is present, that will be given to the CPU unit after program decoding. Okay, so after program decoding, what will happen? Data will go to the CPU. Okay, now you can see there is two data path A and data path B. Okay, so in data path A, this two data path is called as um, uh, processing units. Okay, so data path is equal to the processing unit. Okay, so these each processing unit is having register file A and register file B. Okay, all now this register file A has 16 register. Okay, in register file B also there is a 16 files or 16 registers. Okay, and the size of each register is of 32 bits. As we know that right now we have all the DSP, all the processors and controller which belongs to 32-bit address bit and data address bit size. Okay, so this register file consists of 16 registers. Each file consists of 16 registers, and each register is of size of 32 bits. Now, what is the function of this register files? This register files or unit performs the operations. Okay, what kind of operations? Such as addition, subtraction, which I have mentioned. Okay, so it performs ALU operations. Okay, arithmetic logical unit operation. Okay, so there is a L1, S1 and D1, and here the register for performing arithmetic operation is L1, S1 and D1, and in register file B, the registers are D2, S2 and M2. So here you can see there are 3 plus 3, total 6 ALU registers are there. After that, this is M1 and this is M2. These are the multiplats. So here you can see that in register file A and register file B, total 6 ALU registers are there and 2 multiplier sections are there. Okay, so this is about registers and data path. So paths are the functional unit or functional processing unit, which consists of the registers. Each register is having 16 register. This register file is having 16 registers, and these registers are responsible to perform the arithmetic and multiplication operation. Okay. After that, there is a power down unit. So as we know that to do the processing, okay, this simultaneous or parallel processing, this processor requires more power. Okay, so to lower its clock cycle and to lower down its power, there is a power down unit. Okay, so this is the function of power down unit. Okay, so we have completed this part, that is program fetch, dispatch, decode, the register and its functional unit. Then let's look at the DMA part. Okay, so there is a DMA comma EMIF. Okay, what is EMIF? Can anyone tell me the full form of EMIF? What is the full form of DMA? Those who know, they can type it into the chat box or unmute your mic and you can answer this question. Full form of DMA and full form of EMIF. Quickly. Rohan, unmute yourself. What is DMA, Rohan? Vishal?
DMA stands for
Direct
Direct memory
direct
access.
memory
direct
access.
memory access.
Uh,
And EMIF?
some kind of interface.
Yes. Okay.
External memory interface.
External memory interface. Right. Okay. So here we have a DMA, that is direct memory access, and second is external memory interface. So let's look at first of all DMA. In normal operation, whenever, let me draw the diagram. Just a second. Because I am drawing in the diagram in Word file. So let me know whether it is visible to you all or not. Can you see this?
Yes, ma'am.
Okay. So let's understand the normal memory access operation. So there is a program memory. I will draw. And there is the registers, right? And whenever this register wants to access this program memory, what it has to do? In normal operation, can registers directly access the memory, or it requires permission of some unit? So whenever register wants to access the program memory, it cannot access it directly. Okay, it required to take permission from CPU every time. So whenever it wants to fetch the data, or it wants to store the data, or it wants to access any addressing scheme, then every time it has to take permission from CPU. Okay, so has to take first permission from CPU for this diagram like this. So it will go to CPU first. It will take the permission, and then once CPU grant the permission, then only it is allowed to access the I don't know whether it has this auto rotate. Then it can access its program memory. Okay, so whenever register wants to access any program memory, the normal operation is that it has to, every time CPU will interfere in between Okay, it will allocate or it will grant the permission, and then only register will access those particular program memory. Okay, this is happens in a normal processing scheme. Okay, but in DMA, what happens is, so there is a program memory in DMA, and there is a register. Sorry, register block present. So in DMA, okay, in DMA direct memory access, registers can directly access the program memory, but with the help of one unit, which is called as a direct memory access controller unit. So there is a in DMA there is a DMA controller. Okay, so all the activities are monitored and controlled by the DMA controller, and then this register can access this program memory directly. Okay, so let me show the flow of the path, that is this. So in DMA controller, in DMA, there will be a DMA controller inside that, and with the help of DMA controller, registers are allowed to access the program memory directly. Okay, so this is the function of DMA. So accessing means what? Reading and writing the instruction, right? Then there is a EMIF. So EMIF is an external memory interface. It has a various memory that can be added. Okay, various external memory that can be added, such as SRAM D, SRAM R, SBRAM, and so on. So it can added or access within the DSP processor. So whenever EMIF is accessing the data, that time these two units are separated and united together. Okay, so this is about DMA and EMIF unit. Now let's look at the program memory and data memory. So here we can see that it is written as program cache as well as data cache. Okay, so cache means what? Fast access of memory. Okay, so or easy memory. Okay, easily available or a fast access memory. So here in program memory, there is a 32-bit addresses and 256-bit data available into that. In data cache or data memory, there is a 32-bit addresses, and there is a variable data bit such as 8-bit, 16-bit, and 32-bit. So these are the organization of data memory and the program memory. Okay. Now let's look at the additional peripherals. So additional peripherals are timer, serial ports, and etc. Okay, so here we can see that it is related to this. So here we can see that C6000 CPU family. Okay, this C6000 CPU family follows the VLIW architecture. So VLIW means very large instruction word. Okay, so it means what happens? So whenever the CPU fetches the program, okay, so all the instructions are combined together, and it actually creates a very large instruction word set. Okay, once it means what? It combines all the instructions together in one cycle, and it forms a very large instruction word set. And this a very large instruction word set, which has inside many instructions, these are executed parallelly. Okay, so this is very important feature of the DSP architecture. Okay, so this is a very important instruction. Then here you can see there is a control registers, then there is a control logic, then there is a test, emulation, and interrupts. So as we know that DSP processor handles various interrupts. Okay, so for interrupts and emulation, these are the communication port, and also it has a control and control register and control logic. So control units, control logics, and the interrupts are handled at this stage with the CPU. Now, okay, so till here, anyone is having any doubt? Okay, we'll move to the additional peripherals. Before that, the CPU section and program memory, data memory, and this DMA and IMIF unit, EMIF unit is clear to all. Understood what is the function of this power down unit? As I have seen, I have said that the architecture belong to, it supports VLIW architecture, that is very large instruction word architecture. It means there are multiple instructions are combined together and they are parallelly executed. Okay, so that is why the processing power is very high. So every time to use this DSP processor in a saving mode, or we need to lower down its power, so the power down unit is very essential at this stage. So here it has the additional power down unit for DSP processor. That is why it is performing faster operations. Okay, then uh, hmm, let's look at the additional peripherals. In additional peripherals, we have 5 units. Okay, first is a DMA controller. So it has a DMA. Inside the DMA there is a DMA controller and extended DMA controller. Okay, so here direct memory access is possible. Means what? It directly allow register to access the program memory, and here it has a 4 channels. Okay, so in DMA it has a 4 channel for DMA, that is 4 channel. Actually there are simple DMA controller and extended DMA controller. So first let's talk about normal DMA controller. So in normal DMA controller there are 4 channels. So 4 channels, these channels are programmable, and there is one auxiliary channel which is not programmable. So this is about normal DMA controller, so which is called as the DMA controller. And the second one is a extended DMA controller. The extended DMA controller is works same as your normal DMA controller. The difference between DMA controller and extended DMA controller is, in previous case there is a 4 channel plus one auxiliary channel. And in case of extended, it has a 16 channel, which performs the transferring of the memory and data. Okay, so this is first unit of the peripheral. The second is HPI port. Okay, so HPI port stands for host port interface. It means what? Whenever any host processor wants to access the CPU, okay, so this CPU can be accessed by any host processor, okay, other than the main one. Okay, so host processor, to communicate or interface that host processor with the TSP processor CPU, there is a port which is called as a HPI port. Okay, so this is a direct access port for external host processor to use this DSP processor CPU. Then third unit is the expansion bus. I will just write it down all the names. Just let me explain that first, and then I will write it down all the names. The third peripheral is the expansion bus. So if you don't want to use HPI or EMIF port, okay, there is an expansion bus. Okay, so you can use the expansion bus and you can directly connect with the CPU. In this expansion bus, it operates on 2 modes. First one is a asynchronous mode, and the second is a synchronous mode. Okay, so in asynchronous modes, it acts as a slave and in synchronous mode, it acts as a slave as well as master mode. Okay, so this is about expansion mode. The fourth peripheral is MCBSP, that is multi-channel buffer serial port. So in multi-channel serial buffer port, here during DMA transfer, some data has to be stored. Okay, so for that, this MCBSP port is used to store a DMA, some portion of DMA data into the memory. Okay. And the last one is the timer. Okay, so here timer plays very important role, as we know that. Okay, so can you I will explain the timer part, but can you able to explain what is the relation of the timer and the clock signal with the functionality of any processors or controller? Very, very important. Can you think actually what is happening with every clock cycle or every timer? What is happening actually, and because of that, uh, what is the impact of the DSP processor onto that? If anybody knows the answer, they can write it into the chat box. Anyone? My question is, with every clock cycle, okay, how it impacts, or how it how it impacts on the overall performance of the processor or controller. Let's take an example of ARM controller and DSP processor. Anybody know the answer? They can write it into the chat box. Pranav? Just think. See, when I start today's session, what I said is DSP is used for, it has a ALU unit, and DSP is used for arithmetic, and it is a microprocessor, and it is used for performing arithmetic operations, right? So to perform any processing and operations, okay, so वो operation कब perform होता है, or we can say when instruction is executed at every clock pulse, every tick of a clock pulse, one instruction is executed. So if we increase the rate of the clock cycle, if our clock cycle rate is faster, what will happen? उसका impact क्या होगा? इंस्ट्रक्शंस जो है वो फास्टर रेट में एग्जीक्यूट होगा, क्योंकि एक इंस्ट्रक्शन एग्जीक्यूट करने के लिए वी रिक्वायर्ड वन क्लॉक साइकिल. इफ वी इंक्रीज द क्लॉक साइकिल, व्हाट विल हैपन? इट विल it will faster the execution of the program, right? So that is why the timer is very important for DSP processor to overall increase or enhance the performance of the processor. It means क्या हो जाएगा? Your processing speed, overall processing speed will be faster because of the timer. Okay, so now so here the timer, there are two types of timer. Okay, there are two timers. Each timer is of 32-bit timer. Okay, and these timers are used for timing of event, then to generate the clock, to generate the pulses of the signal. Also, it is used for DMA and EDMA. Okay, the purpose is to synchronize this two, and it is also used for interrupting the CPU. Okay, so the timer is very important part here. Then next is additional features. In additional feature, this is the last point. In additional feature, the hardware is very important. So this hardware supports two types of precision. One is a single precision and the second is double precision. And both the precisions are floating point operators. And single precision, as we know that it is of 32-bit, and double precision is of 62-bit. Okay, and the second feature of DSP processor is, just now I have explained, that is it supports VLIW architecture, very large instruction word architecture. And here it is process 8 instructions per cycle. So every clock cycle it executes 8 instruction. Very important point this is. And it is used in multiplications. So this multiplications handle, as we know that registers are of 32 bits. So if we want to if we consider the maximum multiplication bits, that will be 32 bit multiplied by 32 bit. So it also handles 64 bits operations. Okay, so registers will store 64 bits. Okay, so these are the additional features of the DSP processor. Okay, so I hope now everyone is clear with the architecture. This DSP architecture is very important as far as your exam, university exam is concerned. Okay, so if your exam will be online mode, then also each and every part, there will be many of the questions will be based on this architecture part only. Okay. So I will share this diagram and just go through this diagram. I have created one activity over there that you need to draw this diagram very carefully. You have to draw this arrow very carefully. That is, here we can see that each and every unit and direction is saying something. Okay, so if you are mistaken in the diagram, it is understood that you are not clear with the concept. Likewise, जैसे मैं बता रही हूँ आपको यहाँ पे, this DMA, okay, it is a direct memory access. So when I say it is a direct memory access and it has an internal direct DMA controller which controls this activity. What activity? That is accessing register. Register is accessing directly the memory. So here we can see program memory register program this, it is accessing directly. So here showing it is directly and this is also directly without interfering the CPU. So CPU से कोई भी connection यहाँ नहीं जा रहा है. Okay, so program memory is directly accessing data memory and program memory is directly accessing by this DMA. Okay, so that is why the arrow is like this. Then data path. So here we can see that in program cache memory, the data is coming and result is also storing it over here, right? Okay, as well as this data cache memory, when this program memory decoded the program data, okay, or we can say instruction, then this data is stored into this register as per the decoded instruction, and then it get processed. Okay, so that is why the arrow is like this. Okay, and this unit is connected to the CPU. This is the whole CPU of the processor, and then this EMIF is also connected to the additional peripherals. Okay, so this unit is interlinked. Okay, so this is the architecture of DSP processor. Okay, so today what you have to do is you have to draw this diagram very neat and cleanly, and you have to explain each and every block very clearly. Okay, so you have to start with first of all CPU, then you have to explain second unit as a program and data memory, third unit is a DMA, And the fourth unit is its additional peripherals. And the last one is its features. There are only two features, hardware related features, and it is related to VLIW architecture related features. Okay, so two features. So this will complete your whole architecture of DSP process. Okay. So anybody's having any doubt with this?
No, ma'am.
If you want to ask any question, you can ask. पर्टिकुलर डायरेक्शन यहाँ से यहाँ पे क्यों जा रहा है, व्हाट इज हैपनिंग, फेचिंग में क्या हो रहा है, डिस्पैचिंग में क्या हो रहा है, एनीथिंग एनीथिंग इफ यू वांट टू आस्क यू कैन आस्क. Okay, so I have created the activity over here. You can just check. DSP processor. So here the activity is a second. This is very, very important. So everyone has to draw the diagram on your page, and then you have to take a picture and then you have to upload it. Okay. Very neat and clean diagram you have to draw. And then you have to explain the whole architecture. Okay, so here you have to draw and explain the architecture. Draw and explain DSP architecture in detail. And the instruction is you have to draw neat diagram and show the proper data path flow. Okay. So we have 15 minutes time, so you can able to draw the diagram in 15 minutes. Else we can discuss the architecture. It is up to you. Okay, so you can start drawing the diagram. So let me share. मैंने ये जानबूझ के स्टार्टिंग में ही नहीं दिया this task because I wanted to explain this diagram and block each and every block properly, and then now you are in the position that you can draw the diagram and understand the flow of the data. Okay, so I will just share this diagram in the Google Classroom in the same link, and then you can draw the diagram. Okay, so just let me share it, and after that I will take the attendance and we'll end the session. Okay. Okay, so I have taken the attendance of everyone, and you can start doing the activity which I have just given. I have also shared the PPT, and you can draw the diagram from there. Okay, so if you have any doubt, we can discuss.
Ma'am,
Yes,
we have to draw and explain the architecture, right?
yes, yes.
Okay, ma'am.
PPT. So it is visible, right? Okay, this question is very, very important. And while solving the MCQ questions online test, many of the questions will be based only on this particular topic. Okay, so it is very, very important. That is why I told you to draw this diagram very carefully. Okay, so I have taken the attendance. If you don't have any questions, we'll end the session here and we'll meet next week. ओके, फ्राइडे को भी हमारा ये है ना प्रैक्टिकल है, सो विल मीट ऑन फ्राइडे देन. Also one announcement is there that is related to admissions. I will not name them. I have all the students name, but I will not right now. I will not name them, but those who have not paid the fees, just try to pay the fee. If you're not paying the fee, that is also okay, but give acknowledgement or give something to give your feedback or whatever problem you are facing. So you have to write a mail to the administrator, and then it will be resolved, okay, or we'll give the concession. Okay, so just ऐसे ही आइडियल मत बैठो, जिनको जो भी कुछ है they can directly mail. Okay, so I am not going to name anyone's admission message जो list message जो student है उसका मैं name यहाँ पे नहीं बोलूंगी, but those who have not filled the fees, appropriate जो actions है आप ले लो. जो आपको कंसेशन का है, जो बात करना है कर सकते हैं, या फिर आपको और रिलैक्सेशन टाइम चाहिए, वो भी जो है वो यू कैन मेल विद द कविता मैम. ओके, okay, so we'll end the session here. Can I close the session now? I have taken the attendance already. Okay.